A pride. A pack. A troop. A clan. All are hunters and all gregarious. They evolved to cooperate, communicate and compete. We too live in communities. We take pride in our national identity, and each nation has evolved distinct customs and languages. Within nations, smaller groups have separate identities. None more conspicuous than Scottish clans. A tartan, clan name, traditions, ballads and dialects. Each clan developed its own distinctive character. Now they gather once a year to parade their identities and to compete at games. But there's still more to clans than just kilts.
It's fascinating, this. But to some extent, this clan organization, this clan system, is a relic of the past. A past in which our environment had a much more direct influence on our social behavior.
Centuries ago, each clan had to defend its own land, and the size of each territory was closely related to the geography of Scotland. There were small clan territories in the low-lying eastern parts, but vast ones in the highlands to the west.
This is because the eastern clans occupied low and fertile land suitable for pasture and farming crops. A small area could feed a community. But the harsh western highlands, with their infertile soil, could support little but cattle. So to feed a clan meant defending a bigger territory. These herding clans were more aggressive. Cattle raids were frequent, the cause of many a bloody battle of revenge. The dramatic changes of the last century have weakened the ties of the past. Contests have as little importance as clan boundaries. But the forces that shaped the clans of Scotland still act in animal societies nowadays. And Hans Crook believes that different animal hunters are organized the way they are in response to their environment.
Why does a cheetah hunt alone? And why does a jackal defend a small territory? And why do wild dogs live in packs? In general, why and how did these societies of carnivores, of the hunters amongst mammals, evolve as we find them now?
Hans Crook has been working on carnivores for 18 years. He began in Cumbria, studying how foxes prey on gulls. Then, in Africa, he looked at the gregarious spotted hyena. He darted and tagged individuals. He discovered that up to 80 hyenas can live in one large, loosely knit family group, which he called a clan. Now, Hans works in Scotland on another carnivore, the badger, because there's something about the badger that appears to be very odd. So, with his assistant Tim Parrish, he's comparing the behavior of badgers, both in captivity and in the wild, with that of other group-living carnivores. There are over 220 species of carnivores, and they have all evolved from solitary hunters looking like the present-day genet. From these ancestral carnivores have come today's 7 families. The dog-like ones, and the cat-like ones. Nearly all species are solitary, but 1 or 2 social species have evolved independently in almost all families, like the badgers, the wild dogs, coatis, lions, some mongooses, and spotted hyenas. This variation within one family is strikingly illustrated within the hyenas. The brown hyena is a typical solitary species. It lives in the hot and arid Kalahari Desert. The 2 or 3 cubs remain in the den, usually looked after by the female. Brown hyenas are nocturnal, secretive and rarely seen, so they're hard to study. But one of Hans's colleagues, Gus Mills, has been following them for 6 years, trying to discover the secrets of their solitary way of life. By day, Gus can at least see the tracks they made during the night. He once followed a brown hyena on one of its nightly wanderings for over 50 kilometers. But on average, they walk about 32. That's 20 miles a night. It's on its feet for 12 hours at a stretch. To study hyenas, Gus too must be nocturnal. At dusk, he sets out as the hyenas emerge to forage. It's caught the scent of carrion. It follows the smell and begins to track it upwind. Gus now knows that the hyena will walk in a random way across the desert until it catches a promising smell, when, typically, it will turn upwind to find the source. It can smell food 2 kilometers away. Brown hyenas are scavengers and will share a carcass with others, like the black-backed jackal. But brown hyenas eat other kinds of food as well. And to find out how important the various foods are, Gus Mills has to follow individual animals at night. And there's still only one way to do this effectively, and that's by radio tracking. In search of his 5 hyenas, each fitted with a radio collar, he's traveled thousands of miles. From hundreds of observations, he's confirmed that 95% of all the food taken by hyenas was scavenged. And this was mostly the carcasses of gemsbok, wildebeest and springbok, often killed by lions or cheetahs. However, they also hunt. Tonight, a spring hare. Whatever the prey, it's eaten totally, every bone and every tuft of hair. The tsama melon is one of the most highly prized foods in the arid Kalahari Desert. It's not surprising, since it's over 90% water. Brown hyenas leave chalky droppings. Gus uses these to check on the relative importance of various foods. He's found the hair of large animals, mostly gemsbok, in every one, while only 1 in 3 contains these tsama melon pips. Further evidence: a tortoise shell, the skin of a pangolin, the skull of a springbok. But live wildebeest and other large animals in the Kalahari are ignored. They're too large for the hyena to tackle. Since food is so scarce in this dry, inhospitable desert, each hyena needs a vast range to hunt in. Always on the move, brown hyenas rarely meet one another because there are so few individuals here. Each has a territory to safeguard its food supply. Gus found that these territories were as large as 20 by 20 kilometers. It would seem impossible to defend such an enormous area. But brown hyenas do. They've evolved a striking scent marking called pasting. The hyena drags its 2 anal glands along grass stalks in the territory, once every few minutes, leaving its own signature. The 2 glands each secrete a white and a black substance with a not unpleasant soapy scent. Any intruding brown hyena should recognize at once that an area is occupied. So, they maintain their solitude, wandering silent and inarticulate within their vast, dry range. Noisy and gregarious, the spotted hyena's behavior is totally different.
During my 7 years in Tanzania, I discovered that the spotted hyena's most common prey
were the wildebeest, the zebra and gazelle. When hunting wildebeest, only one hyena selects the prey from the herd. He'll chase it fast, sometimes for up to 5 kilometers. And then more hyenas join, and as many as 15 may cooperate. The wildebeest defends itself very ineffectively, but it's 5 times heavier than a hyena, and a single hyena would have difficulty in bringing the prey down. The victim dies quickly, usually within 5 minutes of being caught. A wildebeest will feed on average 25 hyenas, but to catch it, they must hunt as a pack. Spotted hyenas also cooperate when killing wildebeest calves, which are vigorously defended by their mothers. 2 hyenas are much more effective than 1. I sometimes saw hyenas foraging on their own, scavenging. A foal has just been born and the parents guard it. Soon the scent of the afterbirth alerts a hyena. Whenever I saw a pack of up to 25 hyenas on the move, I knew they were intent on adult zebra as prey. But today, the zebra parents graze unconcerned, because a lone hyena would be ineffective against the stallions biting and kicking.
To guarantee its food supply, the spotted hyena maintains a territory. Females lead the small packs patrolling the borders. These boundaries are exactly defined, and the hyenas frequently visit them, scent marking as they go, in the same way as the brown hyenas. The distinctive soapy smell should leave a hyena in no doubt about where it is. A mistake could be fatal. Hyenas are extremely aggressive towards members of neighboring clans. Often these border patrols have head-on clashes with similar patrols from next door. Usually it goes no further than threats from either side. But here, in the Ngorongoro crater, fights cause about 1/6 of all adult hyena deaths. The most serious conflicts occur over prey killed on the border. The noise may attract a lion who's after their kill. Today, the lions made a mistake. There's no kill, and the hyenas scatter. Cooperative hunting has led to communal living. Each clan has one central den where all the mothers have their cubs, 2 per female. Each mother only suckles her own young. She never carries food back to them. There would be fiendish competition if she did. They must defend a territory big enough in which to catch a wildebeest. Even so, it's only 1/20th of the size of a brown hyena's. It's large and fertile enough to feed a clan of 80. Within the clan, hunting packs form and split. Since any hyena could be a killer or a friend, they've evolved a language of postures and calls to signal their intentions. This striking difference in the behavior between noisy, gregarious spotted hyenas and the solitary, silent brown hyena has evolved in response to their different selection of food. A typical example of a solitary member of the cat family is the cheetah. Hunting alone, it relies on surprise and speed to catch small antelope like these springbok. In the dust, the cheetah trips its quarry and throttles it. The cubs feed wherever their mother makes the kill, because there's no den. Silent and solitary, they move over large ranges without clear boundaries. In many ways, they're typical of all other members of the cat family. All except one, the social cat. Lion prides can be huge, up to 40 members. Like the spotted hyena, they prey on large animals, especially zebra and wildebeest. The lionesses of the pride cooperate to hunt. They're only fast over a short distance, so they rely on stalking. The prey panic. Suddenly there are lionesses everywhere. Most of the lionesses are unsuccessful, but it needs only one of them to tackle a wildebeest to allow the whole pride to eat. Like hyenas, the lions defend a territory. The male marks it by spraying urine against bushes and scraping the ground. Whilst they squabble over food, the lions' real battles are vocal, advertising to neighboring males their possession of the territory and the pride. A bat-eared fox of the dog family wanders on its own through the African savanna, relying on huge ears to find its main food, insects like these termites. It forages, walking long distances, but always within a small territory. The African wild dogs, however, live in packs, hunting over boundless ranges and depending on each other to catch gazelle and wildebeest. For all these African carnivores, there's a direct relationship between food, hunting, and the shape of each society. In Britain today, there are several carnivores: foxes, otters, weasels, and others. Hans has come to Scotland to look at the largest one, the one obviously gregarious species, the badger. It lives in clans, cooperating, and in some ways its society is similar to that of the spotted hyena, lion, and wild dog. Badgers are found the length and breadth of Britain, living in a great variety of habitats, moors and pastures, but mostly woodlands. They live together in groups of as many as 14 individuals, sharing a set, a complex of tunnels and chambers. They're most frequently seen coming out of their holes at dusk, grubbing round in the vegetation, usually interacting, playing with other badgers, often several sows, boars, and cubs together. Within their clan, they sleep together, they dig together, and they play together. Comparing them with African carnivores, you would expect them to hunt together in packs. But the woods of Britain do not ring to the baying of badgers running down deer or cattle.
So, why should these badgers live in groups? Why should they have evolved this group organization? Of course, we just cannot go back in evolutionary history to find an answer to that question, but what we can do is look at differences between badgers as we find them today. Now, for instance, here, I'm now walking over a really large badger set. There are 12 active holes here, and many more holes that are not being used by badgers at present, which have been made in the past last year and perhaps over the last century. But in other sets, you'll find that the setup is a much smaller one. Well, here, under these beautiful oak trees, we've got a group of holes of which only 4 are used. Quite clearly the work of fewer badgers than what we saw up on the hill.
So the size of the badgers' groups is very variable. The aim of Hans' study is to find some relationship between a group's size and its local environment. The first step is to find out how the badgers' clans are distributed within this varied landscape of moorland and birchwoods, pasture and pine woods. Hans knows where the sets are, but where are the territorial boundaries? How big are the groups? To answer these questions means studying the movement of individual animals. Hans and his assistant, Chris Brown, have set 6 traps in the study area on Speyside. The traps are usually put near a set and are checked every day. Though docile when unmolested, a badger can be vicious when cornered, and its teeth are sharp.
It's a pity you can't feel these darts directly from the...
To handle it, Hans must use a tranquilizing dart, loaded with a harmless but fast-working drug, ketamine, which also has the effect of making the badger forget the experience.
In she goes.
It only takes 4 minutes for the drug to have its effect, and then the unconscious badger is recovered from the trap. This badger is a middle-aged male, a bit smaller than usual. It's impossible to follow a badger at night unless it's wearing a radio collar, so Hans prepares to fit one. It'll stay on till the end of the study. The radio collar emits a bleep that can be picked up over a range of several kilometers.
Yeah, it's very nice, because we haven't had any mail in this area yet.
Each badger collared is given a different frequency, so that its movements can be followed independently by tracking with this receiver. The collar carries a fluorescent light to show up in the dark. It's also a chance to record vital statistics. Repeated measurements have shown that a badger's weight changes dramatically with the seasons. But in addition, their weight appears to be related to social status. The badger will soon come round.
All right, mate. Back to your hole again.
It's left at the entrance of a hole close to the trap, where it can recover in peace and then retreat into the darkness. Over 3 years, Hans has radio-collared and tracked several dozen badgers. It has become a routine. In daytime, he can hear the bleeps from underground, telling him in which sets they're sleeping. With a directional aerial, he takes a bearing. When he has a good signal, he follows it up on foot, checking each hole in turn to find out exactly who sleeps where and with whom. Hans quickly discovered that the same badgers will turn up in several different sets. There's no badger here. A few days later, the small radio-collared badger has returned to the hole where Hans left it. But it's at night that things start getting interesting. Despite the darkness and thick vegetation, the variation in radio signals tells when the badger emerges, which area it visits, and how long it spends where. An unwary rustle or a shift in the wind and a night's work can be ruined. In his tracking, Hans confirmed that all the badgers from one set in the middle distance used a specific area, the same fields and the same woodlands, while badgers from a neighboring set beside a loch had a range which didn't overlap it at all. It then became obvious that it was paths made by badgers that in fact marked the boundary line.
Well, here I'm walking on one of these badger boundary paths. This one on the exact boundary between what I call the Burnside clan and the Loch clan. At night, I've very often seen our radio badgers use this path, And it's very rare that a badger from there gets into that area and vice versa. Well, these boundaries, they're not just marked by this beautiful path, but also there are very large badger latrines along these boundary paths, and I've got one right here. It's an area of several square yards where the vegetation has been very vigorously scratched by the badgers, where we find their droppings, very often in small pits which they have dug. And when I was watching these badgers at night, I often saw them squatting, leaving secretions of subcaudal and anal glands here. Well, when I found out about these border latrines, I thought that perhaps I might be able to use this nice behavior pattern to find out more about the whole badger territorial system.
So Hans devised a rather ingenious experiment.
Oh, that's nicely active. These are peanuts. And some nice sticky molasses. Now, badgers just love peanuts. They'll commit any crime to eat a peanut. And what I'm gonna do is feed them these peanuts with these bright red color markers, bits of plastic. I put it in front of the hole.
Tonight, the badgers from this Burnside set will eat the red colour plastic markers. Colour markers are put out every day in spring, when badgers are particularly active in maintaining their boundary latrines. Hans uses a different colour marker for each of the 15 main badger sets in his study area. Here, on a set at the lochside, inhabited by the neighbours of the Burnside clan, he uses a bright blue, conspicuous but harmless. At dusk, when the badgers emerge, they often spend half an hour or more around the holes, cubs as well as adults, picking up anything edible. After a few days, they come to expect the peanut mixture. The little scientific delicacy is very welcome. Badgers digest their food very rapidly and only leave droppings at their latrines. Often, the first colour markers will appear in their droppings the same night. The colours show which latrine they have visited. At night, it's immediately obvious how important these latrines are. Hans uses the hot eye special infrared binoculars, which see into the dark. The badgers walk, often gallop along the border path from one latrine to the next, then stop and use these areas, but not just for defecating. They dig small pits, scrape and urinate. Frequently, badgers also scent mark by squatting, leaving musky gland secretions on the ground or tussocks of grass, rather like the hyenas. Badgers may maintain this fast speed along the boundary path in order to be there for as short a time as possible. Since it is the border, they might meet a neighbour on a similar expedition, and it could lead to a ferocious fight. The badgers maintain similar latrines near the sets as well. But it seems the boundary latrines are the most important ones. And to a badger, they must contain a great deal of information. To a scientist also. In the morning, Hans visits these latrines as eagerly as any badger. He's looking for colour markers, and here, at the shore of the loch, there are red ones, evidence that a Burnside badger visited the boundary. So the colour markers provide information about the clan members' range, which is both quicker and more accurate than radio tracking. On the same latrine, blue markers show that a few days earlier, a lockside animal was here too. Looking down on the area used by the Burnside badgers, Hans could now map the outline of their range, which he found first by radio tracking. Red colour markers left at the set were recovered in latrines all around the boundary. A confirmation of the radio tracking. Using colour markers, badger paths and radioed badgers, all the different clan territories on Speyside could be mapped out. In 1977, there were 8 different territories, but there was a dramatic change the next year. Only 6 territories. 4 had united and 1 split. A puzzle, but at least the exact size of each territory was known. Now, Hans needed to know exactly how many badgers lived in each territory. So again, he used a special technique. You can't count badgers in an area because they all look alike, and you never see them all at the same time. So when caught to be collared, a badger from each territory was given an injection of a radioactive isotope, zinc-65, quite harmless to the badger. For some time, the isotope can be detected in the badger's droppings with a simple Geiger counter. If they're radioactive, they sparkle, as Hans calls it. It's possible to find out how large the group is by finding the proportion of sparkling droppings to non-active ones. And here, at the lockside over a couple of months, he found that in an average of 9 droppings, only 1 sparkled. So since only 1 badger had been injected, there must be 9 in this group. By checking the latrines in all 6 ranges, it was possible to determine how many badgers lived in most of these clan territories. The group size is clearly not related to the size of the territory. So a large clan may either have a large or a small range. So now the exact numbers are known, the exact sizes of the territories are known. Having quantified this, Hans can now formulate his original question more precisely.
So, for a group like this one on the moors, with 6 or 7 adult badgers, with a territory going across the heather, beyond those trees and right over the green field, I'm thinking again about the biological function. There must be a good reason for this. Why don't they have small individual territories? Well, I'm convinced that this has to do with the badger's food, in the same way as the food ecology of the hyenas and these other carnivores was very important for their social organization.
Badgers are omnivorous. They've been feeding on this dead sheep. Another ate a young pigeon that fell out of its nest. Rabbits are dug out as young or caught as adults. And Conopodium, the pignut, provides a popular delicacy in its tubers. Badgers often incriminate themselves in oat fields. They'll pick up cattle food and even take apart dry cowpats to get at the grubs. But Hans only realized how unimportant all these foods were when he went back to the badger droppings. This time, under the microscope, he made a surprising discovery. Thousands of minuscule bristles from earthworms, of all things, and 1 gizzard ring from each worm eaten. Tim Parish and Hans analysed hundreds of droppings from badger clans in several areas of Scotland. Almost every one had earthworm remains, usually masses of them. Results from most areas look very similar. On Speyside, 100% of the droppings had worm remains. Almost all contained an incidental beetle or other insect. A few had rabbit hairs. Some had oats in them, but more had pig nuts. Astonishingly, earthworms are by far the most important food for badgers. And not just any kind of earthworm, mostly one species, Lumbricus terrestris, the largest of them all. It lives deep underground and only surfaces at night. It keeps its tail end in its tunnel for safety while foraging for leaves of grass, clover and other plants. In many places there are vast numbers of them, weighing about 5 grams each, an excellent source of animal protein for those who catch them. The ideal place for badgers to catch worms is short grass, where they can get their daily need of about 200 worms in 2 hours. Hans confirmed this by using his infrared binoculars, watching for the characteristic fast pull and snap as it catches a worm. So if worms are such an important part of a badger's diet, was it the distribution of worms in the countryside that governed the size of the badger's territory? It's not easy to count how many worms there are in a particular area, but there is a trick. Hans pours a very weak solution of formalin on the ground on a sample area. The worms can't tolerate this, so they come to the surface to escape. It takes about half an hour for all the worms to come up. Then they can be identified, counted and weighed. Pasture, like this, contains 19 worms per square metre, of the kind the badgers eat. Hans and his colleagues collected hundreds of samples in different habitats and vegetations. Hans had noticed that one of the badger's favourite places for catching worms was on the slopes under the birchwoods. Surprisingly, though, he found the worms were much scarcer there than in the pasture, only 3 per square metre. The density of worms could now be plotted on the Burnside map. None on the moors or in the pine woods, 3 per square metre in the birchwoods, and many more in the pastures. But the badgers seemed to be foraging very often in places like the birchwoods, where earthworms were less abundant than elsewhere. And there's only one way to find out why. That's to go out at night.
There are lots of earthworms here tonight. The grass is wet and there's a lot of wind, but here we're nicely in the lee of a bit of woodland. Now I've just come from the other side of this woodland, and there in a field just like this one, there isn't a single earthworm to be found. And I think it's because of the wind. These earthworms are for their feeding very much dependent on the weather and the microclimate of a particular place. Which means that now they may be here today and gone again tomorrow. Tomorrow you may find not a single earthworm right here, and lots again in the field on the other side of that woodland.
So the badger's success in finding worms seems to depend on the wind direction. When the wind blows from the west and it's humid, the best place to hunt worms is in the sheltered pasture. But when the north wind blows, worms don't come up there, so badgers feed in the birchwoods. Hans now believes that the Burnside territory can only support 4 badgers because of the limited worm supply in the woodland and pasture. But why then should they live in a group? Each badger could have an individual territory looking something like this, each with a set and a variety of habitats, with worms always available. But no one badger could defend boundaries that were so long. It's much more efficient to live as a group, sharing the defense of one border. So, for badgers too, it's the behavior of the prey, in this case worms, that forces the predators into groups. Beginning now to understand why badgers live in clans, Hans still wants to know how this group living affects the behavior of individuals. Here, at the Institute of Terrestrial Ecology in Scotland, he has established his own clan of badgers in a large enclosure of 1/4 of a hectare. Here, he can watch individual badgers in an almost natural environment. It's important to find out which badgers are dominant and why, how they communicate, why they fight, and which ones mate. There are 6 badgers in this clan. Tim, who's the most aggressive and the heaviest, is the dominant male. Earlier, he terrorized 2 other males to the point where they had to be removed from the enclosure. Then there's Libby, the dominant sow, who with her hair on end is also aggressive towards other badgers. She has had 4 cubs over the last 2 years. 2 males, 2 females. The older twins quite adult now. They've made paths and latrines. They squat, leaving their scent marks all over the area, just as badgers do in the wild. It's a unique opportunity to get an insight into the behavior of individuals within the group. Their scent markings, for instance. It's only by knowing these individuals that Hans found that dominant badgers tend to mark more frequently than others. And in the wild, he can now get some idea of dominant status by looking at the rates at which badgers scent mark. The focal point for all the clan activities is around the set. All members of the group help with digging, but most of it's done by the sows. The vast system of tunnels and chambers is of immense importance to the badgers, especially in winter. This set was started by Libby 2 years ago. In it, she gave birth to her first litter. She may well have her cubs here again next February. While they're still small, she'll have to protect them from other sows. Last year, as the dominant sow, she killed the cub of another female in the group. Tim, the male, and the other badgers assist in dragging large piles of bedding into the set. Here and in the wild, this always takes a great deal of the badger's time. Hans found that badgers only use bedding which is absolutely dry. Bedding should have the right texture. Badgers very much prefer straw to hay or bracken. Also, it should have the right smell. They scent mark it very frequently, especially the dominant boar. If straw has the smell of a badger from another clan on it, they won't use it. In the wild, badgers often will drag bedding like this over a distance of more than 100 meters. It's strange to think that even this behavior is probably another adaptation to earthworm availability. In winter, badgers have little to feed on. Worms don't emerge. So in autumn, they lay down large quantities of fat as a food reserve. Their body weight may increase by 50%. Then they sit out the hard weather underground, inside their set. Going backwards has its problems. All the clan join in bed collecting. Within the group, each member benefits because they share sleeping chambers, bedding and warmth. And even if they have quarreled on the surface, they sleep peacefully together below. At dusk, usually only Tim and Libby are seen on the surface. But later in the evening, the cubs emerge. Libby doesn't take much notice of this year's 6-month-old cub. She keeps grooming. It was believed that weaned cubs foraged for themselves, but near to their mother. In this enclosure, where there are few worms, the badgers have to be artificially fed. Hans was fascinated to discover Libby carrying food to her cub. invariably calling as she approached. He's now also seen this in the wild. Other interesting interactions can be seen while the badgers feed. There's usually no doubt about who is the dominant boar in the group. Wherever there's competition over a juicy bit of food on the set, though the old sow may defend her piece of meat, in the end, Tim always gets it. Aggression within the clan is rare between members of the opposite sex. If the male does snap at the sow, it's frequently followed by an appeasement gesture, a scent mark. Then the female doesn't flee or fight back. But there's more aggression within the sexes, especially between males. Attacked by Tim, this young male, Peter, is at the bottom of the pecking order. He's not given an appeasing scent mark. Quarrels between the males may escalate into much more intense fighting. This fighting always ends with the exit of the lowest in rank. Within the group, by exerting himself, the dominant male has access to more food and he mates more often. The carefully graded status of individuals maintains the structure of the group and in turn affects its size. All this group behavior has evolved to maintain a peaceful coexistence within the clan. It's interesting that the dominant male scent marks the others most frequently, so his signature is carried on all clan members, and it makes them smell the same as his scent marks left in the range, so in the dark they won't be mistaken for an intruder. This small detail of behavior is just one of the badger's adaptations to clan living, which in turn was shaped by its selection of food.
So, after all, the badger is not that much of an oddity in the ranks of the carnivores. As with the lion and the spotted hyena, its diet has determined its lifestyle. But the story of the evolution of social behavior has many unanswered questions. Even my badgers still keep many secrets to themselves.